Assalamu alaikum. I'm Mohammad Shafat Hussain. So this is my lab 2. So for the first question that we see here, that as we just have to firstly understand the code and rewrite it in the Unix. I have done it in the Unix and draw the tree. So for the tree, they said basic informations. So for the tree, we can trace this program and make the tree. Okay, first of all, that we see that is a fork. So this is the first fork that is called. So when this fork called, then it will this will make another child child process. This is the child process. So for the child process, the PDI value would be 0, and for the parent it will be as the child process value, which is 22. So it will be 22 again. So you can see that if it is child process, then just print I love. So then for the child process, it is that I love, and nothing else to do for the child process, so it's finished. And for the operating system, for the main program, for the parent class, it has to do else. It's to go to else. So in the else, it went there, and then it has to print operating system. So here is the operating system, it will be printed. And then for the fork to fork, which is PID2. So PID2 will be again called. So then another, this will be again parent of 23. So this is for PID2 it is 23, and then for the child process PID2 it will be 0. So it is done. Then if it is PID2 equal to 0, then we said that run this, otherwise run this. So for this process, it is a parent, so it won't be PID2 equal to 0, it is PID2 equal to 23. So that's why it will be run at class only. So this way it's class. So then the main function is finished, and then this class function, which is child function will be like this one. So first of all, it will print difficult. So it will print difficult. After the difficult, it will be PID3 equal to fork. So then again in the fork is called. So then another, it will be parent, and this will be the child for this process, fork 3. So in this process, the fork 3 will be 0, and their fork 3 will be 24, as the child process name is ID is 24. After that, as it is run, then the parent and child both has to go through the but interesting. So that's why both has the but interesting, and then the program is finished. So there is the output of this for the question 1. So let us go to the question 2. So for the question 2, we can see that we have to make this one, which is this tree figure process. So first of all, there will be an original clone 1, and then clone 2, then it will go to clone 3 and clone 4. So first of all, we have to do with this fork 1, if left side part. So we go to the we call one fork, which is PID1. I just name it, it's okay, whatever I name it. So PID equal to 1. So then it will be like this, and then if it is for the original one. So if PID equal to 0, that means it is a child program. So if it is 0, that means it is clone 1. If it is not, then it will go to else, right? Okay, so first of all, let us go to clone 1. Okay, here we can see, then we go to the clone 1. So inside clone 1, we can see that we have clone 2 also. So then we again have to call another fork. So that's why I called another fork for PID2, which is fork 1. And then if it is a child program, so that means it is clone 2. So if clone 2, I don't see any output that the question asked me. So that is why it is exit 0. So it will be exited from this process. Again, if I call for clone 1, then they said that if I want to clone 1, then I have to write that I am the absolute version of the recent image, so version of this one. So I just printed it like this. So else I am the version of Eto, and then it will be clone 2. So the value of the clone 2, so ID of the clone 2. So I just get the ID of the, because clone 1 will have the ID of the clone 2 as it is a parent. So that's all. So for this one, we are finished. Then we can go for the clone 3, but for the clone 3 we have to go through the from the else. Okay, so for the else, because inside the original it is here. So p3 equal to fork fork, and if pid3 equal to 0, so means that if we want to go to original to clone 3, that means making another clone for the original. So then we have to be fork 3. We go to the PID for PID 3. From the PID 3, if it is 0, that means it is clone 3. So inside clone 3 I have written this one, and if it is not clone 3, that means it is original. So original, for original we have written this one. Okay, then first of all let's go to the clone 3. So inside clone 3 we can see that we need another clone, which is clone 4. So that's why we make another fork, which is PID 4. So if the PID 4 is equal to 0, that means it is a child program for clone 4, right? It is mentioning about the clone 4. So they said that if it is clone 4, then I have to output this one. So I have outputted this one, finished. And if it is not for the clone 3, we doesn't have anything, so I just put it in empty. So just if, not else. And if as I mentioned that all the things are inside the original, so in the last part it is left with the original, we are left with the original. So for the original we have that else, because we are not going here or going to the original, we are going back to the original. So for the else we have just print that I am the original, and so blah blah blah. So they write in here all the things, and for they want the clone 1 value and clone 3 value. For the clone 1 value we can get it properly, and clone 3 value we can also get it, because it is in the last program, so all the values will be come to here. Okay, so it is normal. But for the clone 3 it is not, because but for the clone 4 that they wanted the clone 3 value. So but because as it parent cannot child cannot have the identifier of the parent, so that's why it will be showing 0. So if we run it, we can see that I'm the original of and this one, and here is the process, and the clone 3 process this one, and I'm the most process this one, because we get from clone 4, which is clone 4. So clone 4 for the I0, because the clone 3 it cannot get the parent values, that's why it is 0. And I'm the obstacle version receiver, so that's the version for clone 1. Okay, so that's all. Thank you.